All right, so let's talk a little bit about interpreting the quantifiers. And really the crucial thing that you should understand about the quantifiers is their interplay, the way the quantifiers relate to one another and the way the variables relate to one another, how the order works, and so on. So let's take, for example, for all x, there is some y, Lxy. If we have something like this, then notice what we're talking about. Notice what's talking about what. So we begin with for all x. So we're saying for any x that you pick, for anything that you pick from the so-called universe of discourse. So remember our little worlds back in the previous video? So here we have our little worlds. And in this world, there are only 4 things. Who knows how many things there are in the world, but this universe of discourse that we're talking about consists of 4 objects. So we say, here when we read for all x, we're saying no matter which one of these you pick, I'll say, so for any x, there is some y, and here y again is a variable. So these are variables, right? So they stand for objects or names. Okay, so when we're looking at the x and the y here, they're both talking about this universe of discourse over here, right? So the y could stand for any name too, right? Except here's the deal. There's some y doesn't mean that you can conclude any of the y. You just know that there is at least one. So one way to interpret this is to say, for any x you pick, there is at least one y, or you can find some y such that, so that's how you'd read that part, this is how you'd read this part, such that x loves y. Okay, so for any x you pick out, there's at least one y that you could find such that x loves y. Okay, so what we're looking at here is a relationship between the elements of this sentence. X, of course, here is talking about this x. The y is talking about this y. And why do we use x and y here? To indicate order. So the order, the relevant kinds of order we have here is the order of the arrow of love. How does the arrow of love obtain between x and y? As we know, it goes from x to y. Right? That's what we're saying the arrow of love does. And then what are we saying here? We're saying here I'm talking about for all x, for any x I pick out, it's going to be the case that the arrow of love travels from that x to some y. Okay? So, let's take a look at what I've given you on this table above here, and I hope you can see it on the screen. If you're using a phone, you're in trouble. So what I've given you is all the possible combinations of variables and quantifiers for this two-place relation. So let's take, for example, for all x, there is some y such that Lyx. Now we've switched up the order in which the arrow of love is moving. Right? So here the arrow of love moves from the y to the x. And what are we saying here? We're saying that everyone is a recipient of the arrow of love. Right? So everyone is loved by. Everyone is receiving an arrow. And where are they getting the arrow from? They're getting the arrow from a y. And who's the y? The y is some y. So everyone is receiving an arrow from someone. Okay? So notice that the switch between for all x, some y, LXY, which says everyone loves someone, to over here, for all X, there's some Y, LYX, is a shift from everyone loves someone to everyone is loved by someone. Okay, so we're reading it this way. We're going from left to right. So here's the person we're talking about. Who's the person we're talking about? Well, the person we're talking about is all the people in the universe of discourse, or all the things in the universe of discourse. So everything is such that there is something such that that something sends the arrow of love to everything. So now by contrast over here, the original one was, here we're talking about everything. Everything is such that there's something such that everything loves that something. Okay, so if we look then at all of the possible switcheroos of all of the possible shifts of the way the quantifiers can interrelate and the way the variables can relate, we've got some redundancy in this table. So what are there? There's 16 combinations or 16 options. If we look at these 16 options, there is some redundancy, but we can move through and see how it works. So, and you can refer to this in the text if you can't see it on your tiny phone. So everyone loves everyone, we've seen. That's straightforward for all X and for all Y, LXY. Everyone loves someone, which we've seen. For all X, there's some Y, LXY. Now notice that it could have been like this, right? So we could have written for all Y, there's some X, LYX. As long as we keep the order consistent such that the for all here is talking about the first place in the relation and the X here is talking about the second place in the relation, then that says there is for all Y, there's some X such that LYX. And that means the same thing as this. Right, that's what I mean by saying there's redundancy. Okay, so now let's look at some of the other variations, some of the ones to keep an eye out for. Someone loves everyone right here. There's some X such that for all Y, LXY. You can go through the rest of them yourself, but let's see, any other interesting ones? Everyone is loved by someone. We talked about that one. Someone's loved by everyone. Someone is loved by someone is straightforward enough. Someone is loved by someone, etc. Okay, so that's how we interpret, that's really what, this slide is incredibly important because it really shows you how the quantifiers relate to one another, how the order of the variables is super important, etc. And so if you play around with reading off different combinations of quantifiers and variables, I hope you'll get the hang of how that works. Okay. Oops. Okay, so let's get back and look at how this stuff can be put into action. Let me clean the board. So now, what we're going to do is begin very informally introducing the way we'd use these things in an argument. And I'll show you some of the rules as we go forward, etc. But for now, I just want to keep it as informal as possible and just begin to familiarize yourself with how these things are going to appear in a proof. So let's take let's read the English first. It says, all philosophers are arrogant. For all X, Jane is a philosopher, and therefore Jane is arrogant. So let's read it again. All philosophers are arrogant. Jane is a philosopher. So Jane is arrogant. Okay, let's go through the formal representation. What we're saying here, and I've given you the translation, is for all X, if X is a philosopher, then X is arrogant. Okay. Next one, Jane is a philosopher. From there, I can say, well, if Jane's a philosopher, then Jane is arrogant. And how do I get that? This is going to be important. We'll see. This is called universal instantiation. And we'll talk about that in a second. and its universal instantiation, maybe I'll talk about it right now. If we have a quantified statement like this, for all x, px, then ax, then I know that no matter what I put in for the x, this will be true. So, for example, p d, then a d. If Diana is a philosopher, then Diana is arrogant. I know that that's true. Why? Because I know that for all x, if x is a philosopher, then x is arrogant. This thing right here, Jane is a philosopher, is a premise. Let's say this is a premise too. So I've got two premises in this piece of reasoning. What are they? Philosophers are arrogant, and the second is Jane's a philosopher. And then I've got a conclusion down here. Well, here's my conclusion. Jane is arrogant. Okay? Now, in order to get there, I had to do a couple of steps. The first step was to move from this premise to something relevant to the argument. So the premise is for all x, px, then ax. The next premise is Jane is a philosopher. And what I didn't know I was doing it, this is ordinary reasoning, but in fact I did it, is I universally instantiated that premise to if Jane is a philosopher, then Jane is arrogant. And I know that I have the premise that Jane is a philosopher. And then I concluded that Jane is arrogant by modus ponens, our old friend modus ponens. So if we were to number these lines in a proof, then line 1 is a premise, line 2 is a premise, line 3 is universal instantiation from line 1, and line 4 is modus ponens from lines 2 and 3. Okay, so let's talk about, I've introduced some new terms. I've talked about instantiation. Well, that's the only new one that I've introduced so far. But to begin with, I think you can see how this piece of reasoning works. So let's do it more cleanly here. Just to review what we did. This is a direct proof that Jane is arrogant. How do we know that Jane is arrogant? Because Jane is a philosopher, and if Jane is a philosopher, then Jane is arrogant. How do you know that if Jane is a philosopher, then Jane is arrogant? I know that because I know that for all x, if x is a philosopher, then x is arrogant. Okay, so that's the structure of the proof. Okay, so we're beginning to see that we need to take the bits of the declarative sentence apart, and once we have the bits of the declarative sentence apart, and once we have a few more little moves, like this move of universal instantiation, then we're going to be able to do some proofs and capture really what it is that we're already doing when we reason about quantifiers. So we're capturing what we're already doing in simple cases like this, but as you can see, once you have this apparatus in place, just think about the n-place predicates, where we talked about predicates that have more than two or three variables. I mean, clearly that outstrips our ordinary capacity to reason about these things, but the formalism allows for that to happen. Okay, so let's take a look then at the interdefinability of these two predicates, or these two quantifiers rather. So we saw this guy here, the existential quantifier, the backwards E. We saw that it reads, for some or for at least one x, blah, blah, blah. We saw, for example, that if you had it embedded, you'd have something like this. Let's say we had a claim, some philosophers are contentious. We could represent this as there is some x, there's at least one x, such that it's a philosopher and it's a contentious thing. So the existential quantifier and the universal quantifier, they're different, but they're interdefinable. So let's talk about the way we would interdefine these two quantifiers. So let's take, for example, I said So if I said, it's not the case that for all x, x is friendly, right? Now, look at this. What does this say here? This says, given what we've seen so far, there's some x such that it's not friendly, right? So if we say it's not the case that for all x, x is friendly, and now look at this one, there is some x such that it's not the case that it's friendly. Turns out that these logically pick out exactly the same models. Remember we talked about models earlier with these little worlds and how the arrows are relating things, right? So these things pick out exactly the same models as one another. Turns out that these are logically the same claim. So it turns out that when we have the negation, let's say, let's pick a different one. Let's say this says, it's not the case that there is some x such that x is friendly. It turns out that that is equivalent logically to everything is such that it's not friendly. So these two formulas capture the same models, the same sets of world, are satisfied by the same models. And it turns out that generally, we're going to be able to interdefine our quantifiers. So if you think about how this works, let's take, for example, let's take this claim. It's not the case that everything is not friendly. Watch what happens. Turns out that that is logically equivalent. So what's happening here? So it's not the case that everything is not friendly is logically equivalent to there is some x such that it's not friendly. And that, of course, is the same as saying there is some friendly x by double negation that we've already seen from our study of sentential logic. So, okay, so by double negation, we get this from this. Okay, so if we say it's not the case that everything is not friendly, notice that we are just saying that something is friendly. Okay, one more time. If we say that it's not the case that everything is not friendly, then we're saying something is friendly. All right, we could take a bunch more examples, or I could give you the rule for how to do this, how to interdefine the quantifiers, which I will do. So basically it works like this. So if you have some quantifier and you have the negation, let's take this one, and let's say it's px. This is going to be logically equivalent to taking the negation, bringing it through the quantifier, and switching the quantifier from a sum to an all or an all to a sum. So this becomes, and it works in both directions, right? So it could go like this instead. It could go, let's say you had some x not px, then that could become, bring it through, flip the quantifier, not the case that for all x, px. And this is the rule of quantifier negation. And quantifier negation is going to be incredibly handy when you're actually doing some proofs. So let's say, for example, you had a situation where you had let's say you had multiple quantifiers. Let me see if I can give myself a clean space here. No? Okay. Okay. So let's take our old friends, someone loves everyone, etc., etc. Let's take the denial of that. Say you had, it's not the case that, let's take everyone loves someone. Say you had that. So you are denying that everyone loves someone. Okay. Quantifier negation will allow you to bring this negation through. We'll flip this, giving you so what does this say? This one up here says, not the case that everyone loves someone. This one says, someone is such that, I'm going to write it out in a sort of awkward way just so you see how this works. Everyone is such that there is not someone such that, and I'm writing it out in an awkward way just so you can follow it, not someone such that the first one loves the second. Now clearly that is a kind of a mouthful. So if you think about that, let's see, what kind of thing is this? If we looked at that again more intuitively, what do you think this might say? For example, let's say we were talking about friendly. It says it's not the case that there's someone who's friendly, right? Or alternatively, no one is friendly. Okay, so no X is a friendly X. Okay, so we can read this as a no one, but I want you to see how the structure works before I start compressing things and doing ordinary language abbreviations on what we're doing. So, okay, so there we are. We got to this point. But notice we can do a quantifier negation again on this, bring it through, and then look what we've got. Bring this negation through, flip the quantifier. Okay. So now what do we have? We've got someone has the relationship to everyone of not loving that everyone. Okay? And to put it in more sort of friendly English terms, what does it say? It says someone doesn't love everyone. Okay, so someone does not love everyone. Okay, so the rationale here is the someone here we're talking about is this. Does not love is right here. Right, so that's what's capturing this. And who are we talking about? Who's the recipient of the arrow or not recipient of the arrow is the everyone. Okay, so as you can see then, quantifier negation is going to be critical in reasoning about contexts of multiple generality. And so that's that. I think we're out of time.